What's up, students? Welcome to the channel. Welcome to my new channel. So in this video I'm going to be taking you through a past paper, which is question 10 from the topic Euclidean geometry, which is one of the topics that a lot of students, when they get into matric, they kind of like had a difficult time with it. So I'm going to be taking you through that step so that you don't have to be so stressed when you need to actually tackle those Euclidean geometry questions. So without wasting a lot of time, let's just get into this question and try to just like solve and what we can do. All right. So the first question, with the first rule that I would actually give you every time when you're solving a Euclidean geometry, so that it does not have to be a big deal to you. It does not have to be a big thing. It does not have to be an enemy to you. You don't have to waste time. This is what you can do. Every time you solve this, make sure that every statement that you read, you pick up something out of it. Okay? If you don't see yourself picking up something out of that, I don't know, which means you've made a mistake. Every time you need to solve it, or maybe every time you read a statement, it has to say something to you. All right? So let's try to see the statement and see what I'm saying practically. Okay? So in the diagram, this is a statement, right? It says in a diagram, ABC, ABCD. It is cyclic what? Quadrilateral. So every time you see a circle with a drawing, even though they didn't tell you that it's a cyclic quadrilateral, you always have to look for what? For cyclic quadrilateral. Cyclic quadrilateral. Cyclic quadrilateral is sort of like a square that touches on the circumference of the circle, with both of the what? The edges, the sides, like this one, this one, this one, and this one. All right. So this one and this one and this one and this one. Now they told you that is ABCD. Now you can see that it touches this circumference, and this one. Right. So now if you read this thing, this is a cyclic quadrilateral. So what is it all about, a cyclic quadrilateral? You know that is if a cyclic quadrilateral, we have it, we know that this one can be equal to this one. Right? Because it is what? A cyclic quadrilateral. It's like this part. Look at this one. This is a cyclic quadrilateral, and this line that extends out of the what? This line. It is extending right straight out of this. Like this is a what? It tells us this. It tells us this one it is equal to this one. Reason being what? Exterior angle of cyclic quad. Right? You know that reason. Hope you know that reason. Okay, so now it made a sense to me. Okay, so I have this one is equal to this one. Put that in your mind. Put that at the back of your mind. You're gonna use that. So now you see I've already answered the question that I don't even know. You always need to actually answer the question that you don't know before you can read the questions, right? You answer that by just simply reading the statement. Okay, so let's see. Okay, so the statement continues and say, let's see, it says such that AC, it is perpendicular. AC, it is perpendicular to what? CB. Every time okay, C is perpendicular, CB is perpendicular to AC, that tells me that between those lines there is a 90 degree. There's a 90 degrees or between those lines, right? So here I've already put that for you. Okay, you don't have to stress a lot about that. Okay, so you keep going. All right, so you go for the other one. So they say, okay, they say this one is equal to this one, and you're fine with that. So and then they say DC is equal to what? MC. DC, oh no, it's not MC. DC is equal to what? CB. What does that tell me? Now, if I have DC equal to this one, and they are inside the circle, like this one and this one. Now, this tells me about the theorem that I you could have done in the beginning of the year. I hope so. This one, I don't know if I can draw it really well, but I guess that's gonna make a little bit of a justice. Like if they tell you that this is equal to this one, which means this angle is equal to this one. Does that make sense? What's the reason? Equal chords, equal angles. All right. So that put that at the back of your mind. So we know that already we know that this is equal to what? To this one, because these lines are equal. It's like this one, then is this angle, this line, this one. The angles have to be what? Opposite the side, right? This is the opposite of the side. This is the opposite of the side. Now this is also the opposite of this side, and this one is also the opposite of this one. Hope that makes a lot of sense. All right. Put that at the back of your mind. So if this one is equal to this one, what does that tell me? It doesn't tell me anything yet. Okay, so let's keep going. Okay, so let's keep, but it can tell me something, because now I have this one, which is equal to this one, and then when I look at this one is equal to this one. So this one, this triangle over here, it is equal to this triangle, because if you take a look at one, this one and this one are equal. This one and this one are equal. This one can be equal to what? C1 and C2. Reason being what? It's over similarity. It's over similarity, I guess so. Do you see what I'm saying? This one, but let's keep going. Let's keep going. I want to show you something after this one. All right, so the statement continues to say AD. Take a look at the AD. AD. See, AD is produced such that M, see, such that M, it's produced to M, okay? That tells me this is a straight line, all right? So there's no curving, it is straight, all right? So such that AM is perpendicular to what? MC. So you know, every time you see something say, maybe they say something is perpendicular to something, you know that lines, that the angle between those lines, you know that is what? 90 degrees. Right, so let's see what the statement is going to tell us. I'm going to be asking from us. So they say, okay, prove that MC is a tangent to the circle. And then you ask yourself, what can I do to make sure that something is a tangent to something? What are the properties for something to be a tangent? Okay, so for something to be a tangent, if you take a look at this one, MC has to be a tangent. For it to be a tangent, what has to happen? It means this angle has to be equal to, let's see, it's going to be like this and this. My page is actually going away. Okay, I put this page over here. So right, which means this page, making a mistake. So this angle over here has to be equal to what? This angle. Does that make sense? Hope that makes a lot of sense. So we know that this one is equal to this one. Okay, we know that is equal to this one. Okay, it's fine. So this one, okay, let's see. This C2 can also be equal to what? A1. Okay, so if that that thing is fulfilled, we know that it's equal to, that tells us that what? A tangent. Okay, so let's see what is going on. So what can we do now? We can say M plus D2 plus C2, which is M plus C2 plus D2 equal to what? Both of these are equal to what? Both of these are equal to what? I want you to take a look at this thing. It's camera one, don't want to focus. So okay, M plus D2, both of these plus C2 are equal to what? 180. So what am I looking for? I'm looking for what? C2. Because I want to make sure that this is equal to what? This part over here. C2 has to be equal to this part, or it has to be equal to this one because this one is equal to this one. Does that make sense? Hope it makes a lot of sense. Okay, so it tells me that what? Angles, you can say angles of triangle, angles of triangle. Okay, so that's the reason. So you go again and then you say A2 plus B plus AC. B equal to what? 180 degrees. Reason being what? Angles of triangle. Some people just like to say interior angles of triangle, which is not a bad thing, just still okay. It's just still okay. Okay, so right, so you can say this one and then you'll be like, okay, now you have A2, and then you have B, and then you have what? ACB. Okay, so what's the way forward right now? So if this one, you know, it is what? It is equal to what? This one. You know that this one has to be equal to this one so that it can be equal to this one. So if this is equal to what? If this one is equal to this one, you know that this is equal to this one. Obviously that means this one is equal to this one. So this is going to tell you that this is a tangent. All right, so let's try to do this thing. Okay, so if you have this one, you can be like, okay, M equal to what? ACB. Therefore, the reason being what? Both of these are equal to 90. Both are equal to what? To 90. So you go again and be like, okay, D2 equal to what? The B, right? So what's the reason around that? The reason being what? Exterior angles of cyclic quad. Stereo angles of what? Cyclic quad. No, I know that my handwriting is not good. Don't have to. Just don't look at my handwriting, but just don't focus on my handwriting. Focus on what I'm saying. All right. So that's what? Exterior angles of what? Cyclic quad. Okay. All right. So if you know D2 is equal to B2, obviously meaning what? C2 is equal to what? Don't forget to put that at the top. Is equal to what? A2. Meaning what? Therefore, you can say, therefore, this is equal to this one. But you know that A2, it is equal to what? A1. Therefore, C2 is equal to what? A2. While A1 is equal to what? A2. Therefore, C2 equal to what? A1. Therefore, I can conclude by saying C2, then I can conclude by saying, now this one, I can conclude by saying MC is a tangent. MC is a what? It's a tangent. Reason being what? Converse. Don't forget this one. This is a very important statement. Converse. Tan-Cot theorem. Tan-Cot theorem. Tan-Cot theorem. I don't know if you can follow this. Right. So now this is our final answer, because now we have what? We have proved the statement. For us to make sure that we proved, or maybe to show that we have proved that this is a Tan-Cot theorem, we have to insert the word converse, because it wasn't like that at first. Okay, so that's how we can actually prove this. First, is that a question? I guess that's a question. All right, so now we go for the 10.2. Right, so 10.2 says prove that A, C, B is similar. It's not congruent. It's not congruent. Don't mix those things. C, D. It says what? Triangle A, C, B. Triangle what? A, C, B is what? Similar to what? Triangle what? C, M, D. How can you actually prove these ones? Okay, so let's see. You can draw this ones if you don't want to get so confused. You can draw this one, and then okay, you'll be like, okay, C, and then B, we have an X over here, and then we also have A over the top of this, which is a A2. You can put a 2 inside. I don't know if that's visible, you know. So yeah, I guess that's visible. So this is a A2 inside. All right. So and then it's similar. It's similar to what? The triangle. You can put it right in this way. Put it in this way. This way. Just like this. Okay, we have the M over the bottom, and then at the top we have the C. I don't know if I'm just messing up things, but I guess that's visible. So the C at the top and also the D at the bottom. Remember, this one is saying D2. It's not D1. Don't confuse those things. This is C2. Now, this is an so what? 90 degrees. And this one is also 90 degrees. All right. So these are the triangles that we have to prove that they are similar, which means they are similar. So we just need to prove that they are similar. All right. So what we can do is we can prove in this manner, because we know that this is equal to what? This is how we can prove it. We know that C, angle C, it's equal to, I think I've missed something. It's not just, I think I've missed something. Oh yeah, it's still okay. Angle ACB, yeah. Angle ACB equal to angle, you can just write M, or you can say CMD if you don't want to get confused. Let's just write CMD. Even if you would have wrote angle M, it would still be okay, because it does not share anything with other angles, you know. So unlike this one it shares with this one and this one and this one. You see, that's where you need to specify. That's what I'm saying. ACB. The middle one is the one that I consider as an angle. Like I said, if they would have requested me to actually write angle, let's say angle B, I would say CAB. The middle one is the one that is an angle. Hope that makes a lot of sense. Right. Okay, that's not a point. So just want to like show you that. Okay, so we know that this one is equal to this one. Okay, so it's just still fine. It's not a problem. So if you know that this one is equal to this one, which is reason being what? Both of them are equal to what? Both are equal. Both of them, you can just write it like this. Both equal to what? 90 degrees. This is mathematics. You don't have to write that in words. You can put it in words, but you don't necessarily need to do that. All right. So that is equal to what? 90. All right. And then what can we do? You ask yourself, what's the step forward right now? How can I do this one? Okay, you start looking and be like, okay, fine. Now I have 9 degrees, and then I also have C2, which I had proven that it was equal to X, right recently at the top. Yes, I have. No, it's not equal to X, but it's equal. Oh, hold on. It's not equal to X, but it's equal to AT. You have proved that at the top. And it's also equal to what? A1. Okay, so let me prove that. Okay, so I can say C2 equal to A2, because I've proven that. proved above. That's your what? Your reason. Proved above. That's simple as I mean, oh, why am I saying up? Above. Guys. Above. Yeah, above. Okay, so that's proved above. So then, obviously meaning that B, angle B, you can just put it as B because it does not share anything with anything. Angle B is equal to what? Angle what? D2. What's the reason? It's just the third angle of triangle. Third angle of triangle. Alright. So if you have this one, what can you do? You can just like conclude. And do not mix those things. The way you have proved them, the way they have put them, and the way you have proved them, do not mix them. Okay? So you have A, triangle A, C, B is similar to triangle what? You know, you said A is equal to what? Is equal to C. So that if A is in the first place, C has to be in the first place. So you're going to say it's equal to what? C. And then you know that M is equal to what? C. It's like this. M is equal to C. So you don't have to confuse those things. Okay? Is equal to what? A C. And then the last one, obviously meaning that it is B is equal to what? Is equal to D. Then this is your final answer. And then you go. Right? So that's how you can actually go for the 10.2. 10 point, I guess that's 10.2. It's 10.1.2, yeah. It's still okay. Alright, so let's go for the other question. If you have other questions, I'm actually gonna you're gonna have to drop them in a comment section. Alright, so we have the other question, which is 10.2. Guys, we're still going. Alright, so this one, it's kind of a little bit tricky if you don't know. If you do not practice. If you don't practice, I tell you this could be a little bit tricky to you. But you don't have to be so afraid. Alright, so 10.2.1. Alright, so how can we actually do this question? Now this is how we can do it. So now we have cm squared, and they say hence or otherwise prove that cm squared over dc squared is equal to what? It's equal to what? am over ab. Alright, so how can I actually do this question? If you want to pause the video, you can pause the video and try to do this one, but I know this one is kind of a little bit tricky. I wouldn't just blame you if you don't do it. It says cm squared over dc squared is equal to what? am over ab. What does that tell me? How can I prove that something can be a square and another one can be cannot be a square? How can I do this one? Well, some people might think, oh, we can actually introduce the square after we just prove these things, but that might not that won't even actually make any. That won't actually take you to the final answer. I know that it's not going to take you to the final answer. It's one of those trickiest questions you can find in your exam. So how can we prove this one? So if you see cm squared, there's this formula that I created when I was in matric. I said it's a 3C's, right? I call that 3C's. So this one means common, and then this one, the E, means equal. If you do math, you know you have to create some formulas. If you don't create some formulas, you know, hey, this thing is going to waste a lot of time trying to figure out some stuff, how to do this thing, how to do that. You have to create some steps, some formulas, so that you do not get surprised. Alright? You know, okay, if I don't use this one, I can use this one. If I do not use one, I can use this one. So I can use this one, I can use this one. You have options. So if it doesn't fit this one, it can fit this one. If it doesn't fit this one, it can fit this one. You know? So this one means simultaneous. 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 That is simultaneous. No, we in maths we don't do spellings. This is not a spelling bee. All right. So okay. So we doing So this one is common. This means it is common, and this one is equal, and this one it means what? I can do a simultaneous. So what can I do here? It means something about this thing. How can I get cm squared? I look at this and I see cm squared is not equal to anything. From a statement is not at all equal to anything. But if I look at this one, I know that is common on both triangles. Which means I can try using a common formula. Right? Okay, let me try to just find the C, and then I'm gonna just figure out other ones. So let's see. So for me to get this one, which means I have to prove the similarity. Okay, so let's try to do that. So it's 10.2.1. So we would say angle A1. I try to prove this one, by the way. So angle A1 is equal to what? It's equal to angle C2. Angle A1 is equal to angle C2, which is something that we just proved. Yeah, we just proved that. It is what? Tan-cut theorem. Tan-cut theorem. Don't need to write the whole word. So it is equal to what? This one. Then this one, this angle over here, it is common on both of this what? Triangles. Maybe let me just try to draw up this triangle so that you don't get confused. So we have the triangle M. The C I'm gonna put it at the top, and then we have the D at the bottom, which is a D2, and then we have C2 over this. So it's sort of like I take the triangle like this, and then I turn it around. Like if you can see this one, I'm not sure if you can see this. This camera doesn't want to focus. So if you take a look at this one, I took this one and I just swapped the triangle like this. I swapped the triangle and so this is how the view looks. Okay, so we have this triangle, which is the smaller triangle inside, and we also have this one in the big one here that puts this one inside. So how can we draw this one? So this one we're just going to draw it the way it is. And then we have C at the bottom, which is C1 and C2. You can say 2, you can say C1 and C2, you can say 2 and 1 inside. You can say, I'm not sure if this is C and 1. Yeah, I'm not sure if you can see it. And then the top one, we can put the A because it was an A. We do not have to change that. Alright. Okay, so we have this one. How can we prove this one? We know that is what? Our A, don't forget to put that at the top. It is an A1. So I can prove that this one, A1 is equal to C2. And M is equal to what? M. It's a common angle. Common angle. Common angle. Try to memorize, or maybe try to know. Every time you practice, try to do the reasons, because a reason is one of the things that can make you get something wrong even though you know it. That's a very important thing, right? So do practice, practice, and practice. So obviously we know that C2 plus C1 equals to what? D2. All right. This one, D2, equal to what? This part over here. Yeah, this kind of it's kind of a little bit tricky if you don't just you have to turn your mind and just turn this triangle. Turn it, and then also at the same time put them on the same track. Like this one is on this one. Like this one is, it's sort of like the same, yeah, you have to just like, if you practice, there's no way you can get this thing without practicing. So now, if you have this one, we can say C1 and a C. Don't forget to put this thing at the top, all right? So this one is what? Third angle of triangle. Of triangle. All right, try to always, yeah. Okay, so so we have this one, so we can prove that this one is what? It's similar to this one. I hope we just actually prove that this one is similar. Okay, we didn't prove that, so can prove that. We say triangle AM C, it's similar. Do not mix those things. Like I said, we say AC, which means I'm gonna put the what? Triangle what? C. And then we say M, and I'm gonna put the M, because now I have an M, so which I can just put the same thing because that's just equal. And then I have the C. This is a C. Do not mix those things. This is a C, this is a C, it's equal what? DT. So I can put the what? The D. Right? So I have proved that is what? Equivalent. I don't want to be so fast. So now if I have this, so what can I do with this one? Because I have what? CM and then DC. What can I do with this one? What does that tell me? It tells me that I can say CM, take this one, it's a CM over DN. CM over what? DN. That's why I always wanted you to just like put the triangles in a way that they just kind of like look the same, right? So is this one the bottom divided by the bottom equals to the what? Equals to the what? AM, just a side divided by the what? The other side. Do not mix those things. Divided by this other side. So if you take from this side, like if you take from this triangle, you go to this triangle, you're also gonna go back again and go take this triangle from this triangle and take from this triangle. So don't say I take from this triangle and then I go to this triangle and then I take again from this triangle and then go. No, that's not how we do that. So we take from this triangle, we go, and then we go back again, take from this one and go take from the other one. So that's how we can actually try to do those things, right? So that's you know, the second, I mean the fourth, I think that's the fifth step, yeah. So we say CM squared equal to what? AM multiplied by DM, because I've just cross multiplied. Why did I cross multiply? It's because I wanted this squared. Like I said, is what? It's common, right? So I can put that as a what? As a first equation, because I cannot do anything with this. Sorry guys, because I cannot do anything with this at all. I can just like leave it from this one, from this point. This is what? Spontaneous. It kind of tells you that this is spontaneous. Right, so let's try to do this one. Then let's go for the other one. So how can I get DC squared? Okay, DC squared. I have DC squared. It is common in both of this one. It is common in this triangle and also in this triangle. But then when I look at this triangle, I cannot prove the similarities with this one, because this one already has the 90 degrees. So this one does not have a 90 degrees. So I cannot prove the what? The similarity in this one. So I might just leave it. So, and the reason also is because why? I have AB. And I haven't used AB here. Which AB is what? Is this triangle. And I know that there's also AM, which I've already used it, and it's here. So what about AB? Where am I going to get the AB? Because now they have the AB. And AB is not equal to anything. So which means I should use this triangle. Because why? Reason being what? I have AB, the first reason, and also DC is equal to what? CN. So that makes me really be like sure that I can use this triangle, because I have this side which is here, and I have DC, which is just the same as CB, because even if I just use CM, It's just the same as like I've used DC. Does that make sense? All right. So let me prove the similarity. All right. So this is what we can do. So we're gonna say in triangle ACB. We say in triangle ACB. Triangle CMD. We know that we can prove this in this manner. Did we prove this thing first? I think we've proved this. We've proved this thing. We did prove this thing. We did prove this thing. This thing we have proved it. This one, we have proved this one, guys. So, which is a good shot. Alright, so if we've proved this one, which means we can just try to do this thing. We can say, because we've proved this one, we know that, let's just try to draw the triangle so that we don't get so confused. Guys, let me remove this one so that you can actually see what I'm talking about. Alright, so we know that this triangle, ACB, let's just draw them so that you don't get so confused. ACB, AC. This one is a 2, guys. This is it kind of looks like this camera doesn't want to focus. Why does this camera doesn't want to focus? So we have the 2, guys. Do watch the ads. I want to buy another camera. Like, okay, so we have the 2 over here. All right, so if you have the 2 over here, it's from this one. It's like this triangle. It's just like take the triangle from that and just like put it over here. So this one is also equal to what? To x, and then we also have the what? The 90 degrees over here, which is still okay. And then it's similar. It's not congruent. It's similar to triangle CMD. This little triangle inside here, CMD. Okay. And let me just turn it around. Take the C to the top, the D to the bottom, and then the N to the bottom because it was there. And then this one is D2 and this one is C2. Alright, why am I putting this C? C2. Alright, so that's not a problem. Okay, so how can we go with this? We know that we can take AC. Let's just take from this side first. Or maybe let me just take from this side first. It's still okay. AC divided by this side. Like I said, you take from this triangle, you go to this triangle. You can take, and then you go back. You can say this one and this one. You go this one and this one. You go this one and this one. Don't say this one and this one, this one and this one. No, it's gonna be a wrong answer, like a big wrong. Alright, so we say AC divided by what? CM. Is that CM? Yeah, it's CM. Equal to what? You can write them all if you don't want to get so confused. If you don't want to get so confused. English, guys, is getting away from me. CB equal to the bottom divided by the bottom, which is an MD. That's an MD. And then it's equal to it's CD, guys. English is getting away from me. Did I do this right? CB. No, I don't have to put this C. I have to put AC. Go back. CB over what? CD. Alright, like I said, AC. Let's check. Quality check. AC, CM. Right. CB, MD. Bottom at the bottom, side and the side, and then this one is a side. AB and CD. Does that make sense? I took from this one to this one, this one, and this one, this one, this one. That's how we do that. But when I look here, I know that I'm looking for what? For DC. I can rearrange. This is a DC, by the way. So CD, DC is still the same thing. 1 multiplied by 2, it's just 2 multiplied by 1. Still the same thing. Don't have to be so confused, guys. This camera does not want to focus. I actually don't know why this camera doesn't want to focus. So right, so we have this one. We have this one, which is a CD, and then We have, if you take a look at this one, I want to show you something. Take a look at this part over here. Like if you take a look at this side, this part over here. I want to show you something. CB is equal to what? DC. Which means I can do something with it. Because I need a C, or I need a what? CD. Just a DC. CD, still the same thing. So which, if I can remove that, I can put the other one. Alright, so let's put the other one. So we have CD, and also CB. Wherever I see CB, I can remove it. AC over CM divided by what? CD over MD equal to what? AB equal to what? CD. Alright. But let me just put this thing in this way so that you guys don't get confused, because I know that there are some people who get confused very easily. DC. I don't want you to get so confused. AB over DC. I don't want you to get so confused. So when I look at this thing, I see DC and I see AM, which I do have at the top, and then I see AB, which is this one. Okay, which means I see this one, and then I also see what? DC, but then I do not see the CM. Do I see the CM? I don't see the CM because I've already proved that I can use it right now because I already have it. So I don't need to use this one. And then do I have this AC? I don't see the AC over here, so I can cut this one out. I can say, because these are proportionally equal. So DC over MD equal to what? AB over DC. So I can like I can see, I hope you actually see what is going, where it's going on. Where it's going, guys, actually. This English, you better bring up in English too, guys. This thing is really killing me. So right, so we have DC, and we have AB multiplied by the what? MD. Right, which is a good thing. Right, so we don't have to be so stressed with this when you get to this point. So now we can see what we want to do. Now we can see where we are going, what we want to do. So we have DC, and we also have what? CM. What can I do here? Because now I have these things, but how can I make sure that these things are equal? I say DC simultaneous. Like I said, what? Simultaneous. I can say because I see CM at the top of DC. CM at the top of what? DC. Okay, which means I can take CM squared over DC squared is equal to what? AM multiplied by what? DM divided by what? AB multiplied by what? MD. This is MD. DM, MD, DM is just the same thing. Like DC, CD. MD, DM, it's just the same thing. I can cancel these things. This one, cancel this one. So I'm left with what? CM squared divided by DC squared equal to what? AM divided by what? AB. Is this the same? Yes, it is the same. This is your what? Final answer. Hope that makes a lot of sense, right? So this is how we can do this. This 10.2.1. It's kind of a little bit tricky if you don't know your if you don't know your theory, or maybe like your basic about the Euclidean geometry. You might have a tough time. Like I said, you can have a tough time. Like, I don't want to lie, you can have a tough time. So you need to put on more practice. So if you want me to show you these ways how to do these things, just click the subscribe button. Click the subscribe button, and I'm going to show you a lot of stuff, how we can actually ace this metric. Click the subscribe button. So let's see this other equation, or maybe like The last question, it's not an equation, by the way, it's a question. 10.2.2. All right, how can we do 10.2.2? Yeah, this thing deserves a long time, yeah? This question deserves a long time. Not this one that we are going to do right now, but the whole of this equation deserves a long time because it's very tricky. All right, so let's see the other one, but don't get the word tricky. Math is not tricky. It needs a lot of practice. I don't want you to get this word with something is tricky. It's not. There's nothing tricky about math. If you don't practice, that's where it would be. Because everything is tricky, guys. Everything is just tricky. That's how life is. Life is just tricky. But if you practice how to do some stuff, you can actually go through everything. Can become a master of mathematics. But then let's stop yapping. Let's try to get to this last question and just wrap this thing up. So right, we have this thing. They say AM divided by AB equal to the sine squared x. Whoa. Where did you get the sine squared, by the way? You ask yourself and be like, why? Where did these people get the sine x? Oh my god. Okay, so how can I get the sine squared? But now I have this one. I have this one. And now it's squared. But this one is equal to this one. Which is this one. This one is equal to this one. How can I do this one? Okay, let me show you how this is done. So you can say D2 equal to what? B equal to what? X. What did I say? I said the what? D2, which is D2 is equal to what? Is equal to B. Okay? Yeah, I see it. Yeah, I see it. Is equal to what? B. Alright, both of these are equal to what? To X. Okay, so it's fine. What's the reason behind that? Is that exterior angles cyclic what? Exterior angles cyclic what? Don't have to mix that with that. Guys, I'm not sure if you guys can see. I can see that you guys don't even see anything. Alright, so exterior angles cyclic what? Right, so that's the reason. First reason. Alright, so we go to the other one. In triangle DMC, this tells us what? What am I saying? Sine D2 equal to CM divided by what? DC. Why am I saying it's equal to this one? Like if you can take a look at this one from this equation, let's put this one over here because this one we've already finished with it. We say D2 is equal to what? This is a sine. It's just like you see. Let me show you using this one because I think this one is the same as this one. Is it? Yeah, is it the same? It's the same. So if you say this one, I don't want to redraw this one because I've drawn it a lot of times. So I'm gonna use this one. So okay. So if you say D2 is equal to B, now you are fine with that because it's equal to X. Okay. So you have X. So we say sine of X because why? The reason why we wanted this to be this D2 to be X is because you have this one as X. Okay, so I'm going to give you the other reasons why we have the other ones. So we have sine D2 over what? CE. I mean sine D2 equal to what? CM over DC. Okay, so CM over DC, which that's not a bad thing. So you ask yourself, where are we going? Why do you say these things? No, let me show you something. So you see sine of X, because this is equal to what? To X. Okay, sine of X equals to what? CM over DC. Yes, we know that is equal to that. So what's going up? So like this is what I can say. Now I can introduce this square. Or maybe let me just put it like this, so that you don't have to get confused. What we do on the right, we also do on the left. We introduce the square. Okay, so what's up with that? You'd be like, okay, this is equal to what? Cm squared divided by dc squared. Okay, then what's up? You ask yourself, okay, what's up? Now this is how we can do this one. We can say cm squared, you know the cm squared is equal to cm squared over dc squared is equal to what? Am over ab. Okay, so that's equal to this one. So what is the way up for from here? So we know that it is equal to this one. So obviously if this one is equal to this one, well, this one is equal to this one. Both of this means they are equal. So you can say this one is equal to what? Am over AB. Reason being what? Is because we proved that this one is equal to this one. And this one is equal to this one. Therefore, this one is equal to this one. Guys, math is something that you need to practice. You don't have to be so stressed. This is a very nice topic. This one is a very nice topic, and it carries a lot of maths. So if you put a lot of practice, you practice, guys, I bet that you're gonna do it. Like you can get 100% within this topic. Like if you can put a lot of practice in there, you're gonna get your 100%. So take care of shillings and pounds are gonna take off themselves. So that's the advice that I would say. Take care of shillings and pounds are gonna take off themselves. Take care of little things, and the big things are gonna come. Because if you take care of how did you come up with this one? You can use that thing to do the big things. You can use that thing to answer the big things. Alright? So you do not need to get so stressed. This is a very nice topic. Mathematics is very nice. Guys, mathematics is very nice. Just put a lot of practice. And then don't forget to like. Don't forget to click the subscribe button, guys. And I will see you in the next video. Peace.